And we have yet another test for convergence of series. This time it's the ratio test, which applies for any series with positive terms. But the ratio test says that if you take the k plus first term divided by the kth term of the series and take the limit to infinity, if your ratio is less than 1, then you're showing the series converges. If that limit's more than 1, the series diverges. And if the limit is 1, then you still don't know whether it converges or diverges, and you'll have to use another test to find out. The ratio test is a particularly useful test when you're working with factorials, exponents, and nth powers, as you're going to see. I have an example here. So let's take the limit of the k plus first term, so that would be 2 to the k plus 1 over k plus 1 factorial, divided by the kth term, and that simplifies and now I can simplify this expression. I know with my factorials, k factorial will cancel out numerator and denominator, and I'll be left with k plus 1 in the denominator. And if I subtract exponents here, I'll get 2. And now if I take the limit, this is going to go to 0. And since my ratio is less than 1, I know that my original series converges by the ratio test. So let's justify our solution. So our series consists of positive terms since the limit, as k goes to infinity, instead of writing the whole thing out, I'm just going to use the notation. I've already shown it above. Since I've shown that that's less than 1, therefore by the ratio test, my original series converges. Here's another series to consider, and again, we got a series of positive terms, so let's apply the ratio test. The k plus first term divided by the kth term. Let's do some simplifying. Just going to organize it this way. Those are equivalent. And I can cancel here k factorial, numerator and denominator. And then here I can subtract exponents. Now in terms of evaluating the limit, I'm noticing something here. If I write my expression like so, I'm noticing that the inside is 1 plus 1 over k to the k. And of course that looks familiar. That's equal to e. And so we've shown the limit is e, which is more than 1. And since our ratio is coming out more than 1, we know that our series diverges. So putting it together, we have a series of positive terms. And since we've shown that the limit of the k plus first term divided by the kth term is more than 1, by the ratio test, we know that our original series diverges.